Hello guys, welcome back to the channel. We are in process of learning advanced DSA and today we will start our sorting algorithms. We have already seen searching. In searching we saw linear search, binary search, their time complexity and other important aspects, their program as well. And today we'll start sorting algorithm, right? But before that, let me just show you. This is our website www.bigdatayatra.com. You can enroll in our advanced courses like Big Data and Apache Spark Mastery. This covers your Hadoop, Python, DSA, SQL, Spark, resume building, LinkedIn optimization, project, 101 mentorship and whatnot at just 3,999. And then we have Python and DSA separate module as well. If you purchase Big Data course, then Python DSA is included in this. You can just check out the curriculum. And this is our Insta page. We have been posting daily tech reels, data reels, so you can follow us. It would definitely give us some motivation to create more content. Yes, so now back to the topic sorting. Like what is sorting? Say suppose I have given one array, right? This is my array. Say suppose 7, 9, and then I have 11, then I have 3, then I have 12. So suppose I have this array, right? Is this sorted array? Is this sorted array? What do we mean by sorted? That is the smallest element will be the first element, and then next smallest will be the second element, and the largest, so on, so on, so on, and the largest will be your last element. That is ascending order, right? We can say ascending order. So arranging, so what do we mean by sorting? Arranging elements, arranging array elements in ascending order is nothing but your sorting, right? Then how do we achieve this sorting in Python, right, or in programming, right? How can I do this? For example, this is my array. If I will sort it, how it will look like, right? It will look like smallest is 3, then 7, then 9, then 11, then 12. This would be my sorted array, right? Currently this is not sorted, and you know we discussed it. For binary search the array has to be the sorted, but for linear search it does not matter, right? But coming to the point, how do we sort it, right? There is a function also which you can directly apply to just sort, but that won't be advisable in your interviews, right? So we have to write program to sort out the elements present in the array, right? So what are the programs when we talk about sorting, right? The very first program which we will see in this lecture is bubble sort. Then there are other programs as well, which we will cover in subsequent lecture, like for example selection sort. We have insertion sort, then we have your quick sort. We will see all of it. Then we have merge sort, then we have heap sort. There are many, but these are some of the major you can say sorting algorithms. Okay, so in this lecture our agenda is to cover this bubble sort. So let's proceed with the bubble sort, right? Let's proceed with bubble sort. Suppose I have this array 7, 12, 9, 11, 3. Is this sorted? No, it is not, right? This is my unsorted array. So what bubble sort says is, and why the name bubble, right? Why the name bubble? Because the idea of bubble sort is to bubble up the largest element towards the end. To bubble up, let me just write it. To bubble up the largest element towards the end towards the end in every iteration. Right? That's why it is called as bubble up, right? When we will iterate over this array A, the idea will be to bubble up the largest element, which is 12 for the very first iteration, towards the end, then 11 towards the second end, then 9, then 3, then 7, sorry, then 3, right? So this is the idea of the bubble sort, right? And how do we bubble up? Right? Let's see, and let's run this bubble sort manually, and then we will proceed with program as well. We will not only see bubble sort, we will also see improved bubble sort, improved version of bubble sort. These two programs we will see, very important, because while going through bubble sort, we'll see that there is some disadvantages in bubble sort, and that's where we need to improve it. Okay, so let's see how it works internally, bubble sort. First, what bubble sort says is, right, so if this is my array, right, it says compare every element. It is present at 0 index, it is present at first index, it is present at second, it is present at third, it is present at fourth. Okay, so what I will do, I will compare these two first, 0 and 1 index first, right? These two I will compare, and I will check, listen to me very carefully, whether 7 is greater than 12 or not. If this condition is true, then swap. If not, don't do anything. Right? So let's see. 7 and 12, which is greater? 12, and 12 is already present at the right side. So we no need to swap, no swap. Here, when we will compare 0 and 1, there will be no swapping, right? Now, next step is compare the next adjacent element. It will be not second and third, it will be first and second. Now these two will be compared, guys. First and second, right? First and second will be compared. This 1 and 2. Now check whether 12 is greater than 9 or not. Yes, it is true. Swap it. So I will swap it, and what my array will become? It will become like this: 7, 9, 12, 11, 3. After the first swap, right? These two will be compared, right? Now my array will look like this, something like this: 0, 1, 2, 3, 4. Now we have compared 0 and 1, 1 and 2. Now I will compare 2 and 3, these two, right? 2 and 3. So now tell me, 12 is greater than 11 or not? Yes, it is. Then swap it. Then after swapping, what my array will look like? It will look like 7, 9, 11, 12, 3. Right? Then I have compared 0, 1. I have compared 0, 1. I have compared 1, 2. I have compared 2, 3. Now 3, 4. These two will be compared. 12 is greater than 3 or not? Yes. Swap it. So after the first iteration, this is how my array will look like: 3, and then the last element will be 12. Okay, so how many comparisons I did in the first half, in the first pass? See, one comparison, 0 and 1, then 1 and 2 got compared, then 2 and 3 got compared, then 3 and 4 got compared, right? 0, 1, 2, 3, 4. 5 elements in the array: 7, 12, 9, 11, 3. How many comparisons? 5 elements. And how many comparisons? 4 comparisons. This is very important, because when we will set the range function of I and j loop, all these elements and comparisons will come into the picture. That's why I'm saying, to understand this, there were 5 elements. I did 4 comparisons, and this is how my array looks like after first iteration, right? 7, 11, 7, 9, 11, 3, 12. Now tell me, the last element or the largest element 12 has been bubbled up towards the end or not? Earlier 12 was at first index. Now 12 is at fourth index. It got bubbled up to end. And this is the idea of bubble sort, that to bubble up the largest element towards the end in every iteration. This is our first iteration. The very largest element got bubbled up towards the end. So I can say this element is sorted now, this element 12, because it is present at my correct position. After every iteration, my largest element will bubble up towards the end. Now I am left with this. Now after first iteration, I have this. So this is it, 7, 11, 9, 3, 12, right? This is my 0th. This is my first. This is my second. This is my third. This is my fourth. Is this sorted yet? No, it is not sorted yet, right? So what I need to do, again, in the second iteration, what I will do, I will again compare 0 and 1, 1 and 2, 2 and 3, 0 and 1, 1 and 2, 2 and 3. But tell me, do I need to compare 3 and 4? No. Why? Because this is already present at my last index, largest element. So let's see, let's go step by step. When 7 and 9 will be compared, 7 is greater than 9 or not? No. So no swap. No swap in this. So I will still have this 7, 11, 7, 9, 11, 3, 12. Now 1 and 2 will be compared. That is 9 and 11 will be compared, right? 9 is greater than 11 or not? No. So no swap. Then 11 and 3 will be compared, guys. 11 and 3 will be compared. That is second and third index. 0, 1 is done. 1 and 2 is done. No swap. When 2 and 3 will be compared, 11 is greater than 3 or not? Yes. Swap it. This is my second iteration. Okay. So I will have 7, 9, 3, 11, 12. Now tell me, after second iteration, the second largest element is present at correct index or not? Yes. The largest element after 12, of course, the second largest element got bubbled up to the correct position in the second iteration. Then in second iteration, how many comparisons I did? 0, 1, 1, 2, 0 and first index, first and second index, second and third index. Only 3 comparisons. Only 3 comparisons I did. Why? Because 12 already got sorted. So I did not compare 11 with 12 again, because it was already sorted. It was already present at the correct index. Okay. So 3 comparisons in second iteration, right? In first iteration, 5 elements, 4 comparisons. In second iteration, it's still the elements are 5, but only 3 comparisons, right? So do you see the J loop is decreasing by the number of I? We'll see again. Let's see the third iteration. But try to think like this, that how comparison is working. When I is 1, you can say second iteration, I will be 1. J is again reduced by 1, that is by I. So this is what we will apply when we will write the code. Let's see the third iteration. I have this 7, 9, 3, 11, 12. I have this 7 is present at 0, 9 is present at 1, 2, 3, 4. These two already got sorted. Yes. So I won't touch them. So what comparison will be done? 0 and 1 will be compared. 7 is greater than 9. No. So no swap. 9 and 3 will be compared. 0, 1 and 1, 2. Now when 9 is greater than 3, yes. 9 is greater than 3, yes, right? So swap it. So after the swap, I will have 7, 3, 9, 11, 12. This is my third iteration. 0, 1, 2, 3, 4. And in third iteration, how many comparisons I did? 0, 1, 1, 2. That's it, 2 comparisons. So in third iteration, value of I will be 2, right? Then again, my j got decreased by 2, right? So yes, this is how it is working. So j got decreased by 2, that is length of a minus I, and then minus 1. We'll see the formula of j, right? Then fourth iteration, now I have this with me. 0 and 1 will be compared. Yes, it will be compared, right? 9, 11, 12 are already sorted. I won't touch them. So 7 is greater than 3. Yes, swap it. A equal to 3, 7, 9, 11, 12. Now in fourth iteration, how many comparison? Only one comparison, that is 0 and 1. And now I have got the sorted array 3, 7, 9, 11, 12. This is your bubble sort. Now let's come to the formula. All right, this is my array. This has 5 elements. This has 5 elements. How many comparisons I did, guys? Right, how many iteration? First let's talk about I loop. We definitely need 2 loop. We know we definitely need 2 loop. Why? One for this, the outer iteration, one for the comparison and swapping. Okay, first loop for array iteration, second loop for every iteration we are comparing, right? For every iteration we are comparing and swapping. So we need 2 loops, but which loop will run till what point? This is what we need to identify now. Which loop will run till what point? Okay, so let's see. A is sorted now, 3, 7, 9, 11, 12. Right, this is sorted. This has 5 elements. How many iteration I did? 4, right? In fourth iteration, all the elements got sorted. So I can write like length of A will give me 5, right? Then I need to subtract 1 from it. Then it will give me 4. And I loop will run for 0, 1, 2, 3. So in range for I loop, can I write for I in range length of array minus 1? This will be my I loop. Why? Because I am doing comparison total elements minus 1. Total elements minus 1. There were 5 elements. Suppose I have this array, right? Let's again write some unsorted array. 2, 30, then I have 12, then I have 25, say suppose, right? Though I have total 4 elements, but I will run only 3 times in 3 iteration. Let's see, you yourself see. Again let's see. 2 and 30, 0 and 1 will be compared in the first iteration. Let's see, in the first iteration, the ith value 0. 0 and 1 will be compared. 2 is not greater than, so no swap. 30 is greater than 1 and 2 will be compared, so swap. So I will have this 0, 2, 12, 30, 25, and then 1 and 2 will be compared, right? So I will have this after first iteration. How many comparison I did? 3 comparison. 3 comparison, and after this I have this. In second iteration I have 2, 12, 25, 30, right? Then in second iteration 2, 12 already sorted. No, when it will compare 12, 25. So what comparison I did? 0, 1, 1 and 2. 2 comparisons. Then in the third iteration 2, 12, 25, 30. These 2 are already sorted now. So 2 and 12 will be compared, which is already sorted. So I will run 3 times. Again, in this you saw that array got sorted after the first iteration. Then why I ran second and third iteration? This is nothing but your modified bubble sort. We'll see. But for now, you understood that I need comparison. I need my I loop for total number of elements minus 1 times. Total number of elements minus 1 times. So I hope it is clear. So this will be my formula for I loop. Total elements, if total number of elements are 5, I will run my I loop only 4 times, right? That is the total number of iteration I need, right? Let's see. Now let's talk about comparisons. let's talk about comparisons, guys. Let's say in this case, for the very first iteration here, 0 1 got compared, 2 1 and 2 got compared, 2 and 3 got compared, 3 and 4 got compared, right? For the very first comparison. Four comparisons for the very first time. 7 9 11 3 12. Let me just write it. 7 9 11 3 12. This is what, if I is 0, right, I will compare j value. Now j, I am calculating formula for j. 0 1 1 2 2 3 3 4. 4 comparison. When I is 0, when I is 1, this will be at the correct position. So I will compare 0 1 1 2 2 3. 3 comparison. When I is 2, how many comparison? Now 11 will be here. So only 2 comparisons. 0 1 1 2. The 2 comparisons when I is 2. So I can say that the comparisons are decreasing as per the value of I. So I am decreasing I from j, right? So what the formula for j will be? Very straightforward. Let me just write the formula for j. It will be nothing but, for j in range, length of array, again if there are 5 elements, 4 comparisons, but it is decreasing with every I. So I will reduce I from it. Length of a minus 1, it will be same, but j loop is decreasing with the every I value, right? So these two will be my loop, right? As I am applying 2 loop here, what I will do now I will compare if array of j is greater than array of j plus 1. If yes, swap it. That's it. This is a bubble sort. Now time complexity. This is running n times, that is length of array, right? We can remove this constant. If you have not seen the time complexity video, do watch it in the playlist, do watch it in the course, then watch this. You will see. I will remove this constant to calculate time complexity. I will remove minus 1 minus I. So it is running for length of a, that is total number of elements, that is n times. It is running for n times. 2 loops running for n times. So it will be on into on, which will be on square. So this is your worst case time complexity for your bubble sort, or time complexity for your bubble sort. This is it about bubble sort. Yes, but we will see one modified function as well in bubble sort. But let me just code it out and you will yourself see. The bubble sort program I have, let's say array as 7 3 9 7 12 9 11 3. Let's say this is unsorted array, right? What I will do, for I in range, length of a, total number of elements minus 1 time comparison. For j in range, the inner loop will run same as I loop, but for every y value the comparisons are decreasing. But for every I value the comparisons are decreasing. We saw that for the very first time the last element will come at the correct position, so number of comparisons will decrease, 3 2, then lastly 1. So number of comparisons are decreasing as per the value of I. So I need to subtract I from it. Then simply I can just say if a of j is greater than a of j plus 1, that is every element it will check for every loop. That is, for the first iteration j will run how many times? Let's see. J will run how many times for the very first iteration? I will run for 4 times. So when I is 0, j will run for how many times? Length of a 5 minus 1 minus, that is 4. 4 minus 0, 4. So j will run 4 times. So j will run also 4 times when I is 0, right? It will run 4 times from 0, 1, 2, 3. So I am saying a of j, a of 0 is greater than a of j plus 1, swap it. Then j will become 1, j of 1 is greater than j of 2, then swap it. Something like this I am writing, and I will write swapping condition now. Swapping condition will be simple. A of j plus 1 equal to A of j plus 1. Simple, right? A of j. It means I am putting A of j plus 1 in the position of A of j, replacing it, and A of j in the position of A of j plus 1. Simple. This syntax means self-explanatory. A of j will be replaced by A of j plus 1, and A of j plus 1 will be replaced by A of j. Normal swapping. No issues. That's it. This is my bubble sort. Let me now just print A. That's it. It will be sorted. Let me just run it. Yes, it is sorted. 3, 7, 9, 11, 12. It is sorted. Simple bubble sort. No issues. But there is one issue. There is one issue with it. There is one issue with it. Let's see what. There is one issue with this program. This can be improved. This can be improved. How it can be improved? Let's see. How it can be improved? Let's see. Say suppose I have this 210 and then I have 825. Suppose I have this. Or let me just do it like this. This will not be much clear here. Let me just interchange the elements. I have, say suppose this, like this. I have 25 here, I have 10 here. Okay, I have this array. I have 0 index, 1 index, 2 index, 3 index, right? Array. Let me just apply bubble sort. 2 and 25 will be compared, right? No, 2 is not greater, so no swap. 25 and 8 will be compared, so yes, swapping will be done. So what it will look like this. Now it will look like this. 8 will come here, 25 will come here. Now 25 and 10 will be compared. Yes, then swapping will happen. Now I have 10 here. I have 25 here. So 3 comparisons, 0, 1, 1, 2, 2, 3. I 0. And J ran for 0, 1, 2, 3 times. That is length of A minus 1 minus I. Length of A is 4 minus 1 minus 0 3 times. That is for 0, 1, 2. Simple, right? Now I is 1. Now I is 1. Tell me. Now look at this. Array is sorted or not? Array is sorted or not? My answer is yes. Array is already sorted. 2, 8, 10, 25. In the first iteration only array got sorted. In the very first iteration array got sorted. But I am running I till when? Length of A minus 1. That is 4 minus 1. 3 times. So I need to run I for 1 as well. I for 2 as well. But does it make sense to run? Let's say when I will run for I equal to 1. So this won't be compared. 2 comparisons will happen for this. 2 comparisons will happen. Now why 2 comparisons will happen? Because length of A 4 minus 1 minus 1. So 2. So J will run only for 2 times 0 and 1. So 2 comparisons will happen. 0, 1, 1 and 2. 2 and 8 will be compared. It is already sorted. 8 and 10 will be compared. It is already sorted. So I will have array like this only. No swapping. For I equal to 2, 1 comparison will happen. 2 and 8, it will be same like this because it is already sorted. So my array got sorted in the very first pass. So my array got sorted in the first iteration only. I ran it for 1 and 2 unnecessarily. So what I can do, when I will run for 1, in this case only, I can identify whether the swapping happened or not. Whether the swapping happened or not. If no swapping has happened, I can terminate. I can basically break or terminate the loop when I was 1 only. I will break at this point so that it does not run for I equal to true. And say suppose here we have only 4 elements, right? Say suppose we have 100 elements, right? So I loop will run for length of A minus 1. That is 99 times. You saw, right? When we have 100 elements, I will run for 99 times. But say suppose when I was 0, all the elements got swapped. Then why to run for I equal to 1, 2, 3 till 98? Right? Because I will run for 0 to 99. So if I has run for 0 at time, so why to run for 98, right? This is a wastage. So instead I can identify if there is no swap or not in the next loop, and then I can break it. This is what I can do, and this is what we achieve it in the modified bubble sort. So we maintain a flag called as is swapped. You can name it as if there is no swapping in the next iteration, that is I equal to 1, we will break it and we won't run it for next subsequent values of I, that is I equal to 2 in this case. So let me just go and implement it. What's the array? Array is 2, 25, 8, 10. Let me just do it. 2, 25, 8, 10. So I have only one unsorted. So in the very first pass, 25 will come at the last index and I will have my sorted array. This is my normal bubble sort. Let me just run it. I have it. But let's check for how many times I ran. Let's print the value of I. See, I ran for 0, 1, 2. That is all the times. Even though my array got sorted in the very first iteration, the I ran for 1 and 2 as well. But there is no need, right? So I can modify it. So I will write modified bubble sort. And I will just do this. I will take this. I will copy it. I will still print the value of, let's print the value of I so that we can compare. I will make is swapped as false. This is the flag I am maintaining. And when there is a swapping has happened, I will make is swapped as true. When the swapping happened, I will make is swapped as true, right? Is swapped as true. So what I will do, I will now check if not is swapped. That is, if is swapped is still false. That is, if not false, it will be if true. So if is swapped is still false, because is swapped would have been turned true if swapping has happened. But if it is still false, let's break the loop. That's it. This is your modified bubble sort. Here I will run only for 0 and 1 now, because in the first, when I is 1, it will identify that there is no swapping has happened and it will break the loop. It won't run for I equal to 2, right? It won't run for I equal to 2. So let me, I think indentation is not correct. Yes, now it is correct. Let me just print the value of A, the list. Let's print it. Print is not defined. Okay, sorry, my bad. Here, print will come. Let me just comment it so that you understand only the modified bubble sort part. Yes, let's run it. Yes, see, I had this 2, 25, 8, 10. This time I only ran for 0 and 1, because when I ran for 1, it identified that there is no swapping has happened and it break the loop. And I have 2, 8, 10, 25. I hope it is clear. We have seen both the modified and not modified bubble sort. You can practice on your own. We'll meet in the next sorting algorithm.